Hello students, welcome to this another session where we are taking JEE Main Test 58 released by NTA on the Abhyas app. Now today I've solved the paper. The paper is not that difficult, but it's tough to say the questions are easy. Direct application based question, single step, double step question, I have only found two questions. Rest all are these medium can somewhat be regarded as tough, and this tough are tough means because basically the concepts involved are of advanced level. It's not the usual concepts. There are hardly any question which you can directly take. So it will be a time-taking paper. It won't be an easy paper for sure. So here again, I'll say any score of 55 plus for an average or above average student is okay. And for good student, again, 75 plus is what you should be aspiring for. Because for good students, I mean the students who are good at advanced level, they should find it not that difficult. But those who are not up to the advanced level, the solving questions is not that easy. You have the riverboat problems, you have that constraint motion, you have that LOM problem. So it's not an easy paper for a normal student, though it appears easy for a student preparing well for JEE Advanced. So let's start the paper. First question. An electron in a hydrogen atom is in orbit from which there can be a maximum of 6 transition. Let's say if it is nth state, the maximum number of transition when it returns to ground state is n9 minus 1 by 2. That is 6. You directly can make out this is equal to 4. So this is n equal to 4. Another electron is in different hydrogen atom is in an orbit where there can be a maximum of 3. So again putting the same result, now equating it to 3, you can directly make out it would be n equal to 3. So one is 4, one is 3. Now the ratio of the velocities, velocity is proportional to z by n. So directly we can say v1 by v2 would be equals to n of 2 by n of 1. That is going to be 3 to 4. So it's a easy one for you. Option D, not much time taking. Now the second one. In the figure shown, no friction at any contact surface. Okay, no friction at any contact surface. Initially, spring is not deformed. What would be the maximum deformation in the spring? Consider all the strings to be sufficiently large. Consider the constant to be k. So because there is no friction and it specifically asks for maximum deformation, we'll go by work energy analysis. So let's assume the maximum extension be x max. So if the maximum extension be, let's say, x max, if I can write, let's say this is equal to x max. So then what we'll have, first of all, if I draw the FBD, this is F, so this is also F, and this will become 2F. So if I take it here, it would be something like this. This is M, this is 2M, this force acting is 2F, and this will be acting as F. Okay, so this is the equation that we are getting, 2F and F. Now you have to find the maximum extension. So for maximum extension, now it's a 2 block problem connected by a spring. We go in the C frame first of all. That is the standard one we do. It is not directly given, but we have converted it. So first of all, what is the acceleration of CM? That is the net force, which is F over what is 3m. That is the ACM. So if I do in the C frame, what I see in the C frame now, if I observe them in the C frame, there will be some different forces that would be acting over it. And what would be those forces? Let me check. That would be equal to, let's say, this is F, and because Cm goes there, so the pseudo force will add up, and that pseudo force on this one would be this F pseudo Fp1 that I can write, that would be equals to MACM, which is M into F by 3m, that is F by 3. So F plus F by 3 becomes 4F by 3. And for this one, if I have to calculate, this would be 2F, this would be subtracted, and it would be multiplied by 2. So it is F by 3, this would be 2F by 3, so that would be 2F minus 2F by 3. So again it is 4F by 3. So now this is a standard case for you. This is 4F by 3, this is 4F by 3, and this is K. So now what is the maximum extension? So what I tell, go by the energy analysis thing. So what we'll have, when there will be x max, both would be moving with VCM. So in frame of CM, velocity of 1 with respect to CM and velocity of 2 with respect to CM, both will be 0. So both will be 0. So what I can say, let's say it goes x1 distance, it goes, let's say, x2 distance. So what I can have, 4F by 3 into x1 is the work done, 4F by 3 into x2 is the work done, and that would be equals to, what I can say, that would be equals to half k total x max, which is x1 plus x2 ka whole square. So we have to calculate this value of x1 and x2, that is we need to find it out. So this is the first equation that we have got. So now putting all these values, forces are same, this x1 plus x2 comes out, so 4F by 3 x1 plus x2, here half k x1 plus x2 whole square, so the power will be cancelled. So this is x1 plus x2. Directly you can make it out as a df by 3k. So it comes out easily. So go for option B. So it's a good question for you. You must do this. Next one. A small coin of mass 40 grams is placed on the horizontal surface on a rotating disk. Disk starts from rest and given an acceleration alpha here. Okay. Coefficient of static friction is this, kinetic is this. Coin is placed at distance 1. The magnitude of the resultant force on the coin exerted by the disk just before it starts slipping. So just before it starts slipping. So before it starts slipping, Fs acting would be Fs max. So I'm pretty sure that is equal to mu s n mu s mg. So if I do this, this is 3 by 4 and this Fs would be acting like this. One component along center, one along tangential, and that would be the net force that we'll be getting. The net friction, basically, we can say. Mgm is what we have, 40 grams, so 40 into 10 to the power minus 3 into 10. So what we get if you do this, this is 0.3 Newton. But again, just see, it is exerted by the disk, not by friction. So disk is exerting that R force that we generally write, that is N plus F. So F is Fs max and N is equal to mg. Mg would be equals to, I can directly write 0.4 Newton. So therefore the magnitude of R would be, because both are perpendicular, one is vertical, one is horizontal, that is 0.3, 0.4. You are very much familiar, that is 0.5 Newton. So be aware, friction is 0.3, but the question is not asking for 0.3, it is asking for 0.5. Okay, next one. A cell of EMF E and internal resistance small r supplies current for the same time through external resistances, okay, separately. If the heat developed in both the cases is same, okay. So what is the heat developed in both the cases? In the first one, what I will have, the current would be equals to E upon R1 plus R. So that square into the heat developed in both cases. So heat developed, now there can be two meaning. Heat developed could be the net heat developed, and or it could be the heat developed in the resistor. So I'm assuming it is talking of external resistor, so that is R1 power into time, and that is equal to, in second case, similarly you can write E upon R2 plus R whole square into R2 into T. That is what we can write here. Okay, so otherwise, if we take the total heat R1 plus R, R2 plus R will cancel and we'll get R1 equals to R2, which is not, that R1 is not equals to R2, so cannot be possible. So I'm taking this case only. So this TTT get cancelled. So what we now get, E square, E will get cancelled. What I get, 100 upon 100 plus R square is equals to 40 upon 40 plus R whole square. Okay, so this is what we get. This is what we get to. So doing it at 10 by 4, so it would be root 10 by 2 would be equal to 100 plus R upon 40 plus R. So what we can have, 40 root 10 plus root 10 R equals 200 plus 2R. So now what we get, we get a root 10 minus 2 times R is equal to 200 minus 40 root 10. So R is equal to 200 minus 40 root 10 upon root 10 minus 2. Typically, root 10 is approx to 3.1 or 3.14 or 3.2 approx. If I take close to 3.2, so it would be, well, let's say 3.2, it would be 1.2. And if it this is 3.2, so 40 into 3.2 would be 128 something. So above we will get 70 something, 70, 72 over 1.2. So this is 60 is close to 60, that is the value we are getting. So it would be 63.3 going by the closest option, or you can do more carefully if you wish. I've just taken the approximate route. I am confident enough to go for that. Otherwise you should solve first. Next, we have an equilateral triangle ADC of uniform specific resistivity having some resistance is pulled with a constant velocity v out of a uniform field. Okay, at equal to 0 side DC of the loop is at the edge of the field. The induced current versus time t. So what, because it is going with constant velocity, taking this, what we need to know, at any instant after t it would be like this. So the length that is being remaining over this would be equals to whatever I can say. If this was h, this will be h minus vt sort of something. Okay, now if I take this, this is the way, and this is the length that would be that BVL. So we know EMF would be BVL, and what is this length L? I can directly say, let call it be capital L, going by the logic of the you can say the similar triangle AAA similarity. I can if because it is an equilateral, it will become an isosceles triangle, so no issue for that. So what I can make out directly, that L by H would be equal to L upon H minus Vt. So substituting this, the EMF would be BV L upon H into H minus Vt. This would be this. So the current would be a straight line function, and it should be decreasing with time. So As per this, B option seems to be the most appropriate. Nothing also, any option is linear. So go for fifth one. Now go for the sixth one. Now the sixth one. Insulating solid sphere of radius r charged in non-uniform manner such that charge density is inverse to r. Okay. Where a is a positive constant and r is the distance from the center, the potential difference between center and surface. So for finding potential difference, first let me check at any distance x from the center what is the field. So to find the field, I will do that. Let's say small r I should write. I need to integrate it. So taking x and going x and taking a small shell of dx, the dv would be what you write 4 pi x square dx, and the charge dq would be rho dv, that is a by x into 4 pi x square dx. So what we get now, 4 pi a x dx. Now therefore q enclosed till that time would be equals to integration dq, that is 4 pi ax dx from 0 to r, and if I do this, this comes out as 4 pi a r square by 2, and the e will be kq enclosed by r square, and that comes out as, because of spherical symmetry I'm using this formula, 1 upon 4 pi epsilon naught into 4 pi a r square by 2 upon r square. So it get cancelled. What we get? We get a upon 2 epsilon naught. That means the field is constant. So because the field is constant now, because it is a constant field, so magnitude is going to be constant. So if I go along this line, the field is constant and radial. So the difference of potential between the 2 points would be equals to E into D. D is here R. So it would be A R upon 2 epsilon naught. So as per the given options, it looks like D should be the answer. Next, moving ahead, seventh. Suppose the gravitational force varies inversely as nth power of the distance, then the time period of the planet in the circular orbit around the sun will be proportional to this question. I have done so many times, I remember the answer. I'll tell you the logic. Because let's say force is inverse, so k upon r to the power n, that is equal to m omega square r. So what we have, well, the result that we get is omega square proportional to 1 upon r to the power n plus 1, omega proportional to 1 upon r to the power n plus 1 by 2, t is inverse to omega, that is r to the power n plus 1 by 2. So go for option C. So this is a question asked many times. I remember the answer. You must also be, you might be remembering this. Yeah. A rod of length L laterally thermally insulated of uniform area A consists of material whose conductivity is a function of temperature. Okay. B are constant T1 and T2 less than T1 are the temperature of the two ends and the rate of flow of heat. So what we have. So let it be the rod. This is T1. This is T2. Okay. So let's say take it in any x, set it is, this is a small gap dx. Because all such are in series, I can directly write h is equal to same, that is equals to minus ka dt by dx. And if I write this k, what I get and write as k as k naught upon k naught a plus bt into a into dt by dx. And this is h, that we can write h is going to remain the same. So now what we have now, we have this, you have to find the rate of heat flow. So this is the rate of heat flow. So let's integrate it. H dx is minus k naught upon a plus bt into what we have, dt. So doing this integration, x varies from 0 to L, t varies from t1 to t2. So minus k naught is common, 1 upon a plus bt, that would be ln of a plus bt. So a plus bt2 t2 upon a plus b t1, and because this is b integration, so it is 1 by b, I can directly make it out. So this is the result that we get, and this is h into L. So what is the value of h? H comes out as minus, I can adjust how? By that reversing this thing. So this t1 goes up and this goes down. So this is k naught by bl ln of a plus b t1 upon a plus b t2. So this is what I'm getting. So what is the result? And I've missed a. Okay, so this would be a. So this comes out to be option C. That is the most appropriate one I can see from here. Okay, next one. Question number 9. An ideal diatomic gas undergoes a thermodynamic process as shown. The process AB is isoporic while BC is isothermal. Okay, total heat given to the gases. So first of all, what is QAB? QAB, what you write it as NCV delta T. CV is dia, so 5 by 2 NR delta T, that you can write it as nRTB minus nRT, and at any moment nRT is PV. So from our knowledge of that gas laws, this is 2 P naught V naught minus P naught V naught. This comes out as P naught V naught. Okay. Now QBC, because it is an isothermal, this is W. W is nRT ln of V final upon V initial, that is ln2. Now what is nRT? I can write from B or C anything because it remains the same. So it is 2 P naught V naught, from B I can write ln2. So what is the net heat? Net heat would be addition of this. So 2.5 plus 2 ln2 V naught V naught, and ln2 is 0.7, so approx 0.7, so it is 1.4 plus 2.5, it is 3.9 P naught V naught. I can tick option C from the given choices. Next one. A man crosses a river in a boat. If he crosses the river in minimum time, he takes 10 minutes with a drift 120. Okay, if he crosses the river taking shortest path, he takes 12.5 minutes. So first of all, minimum time means this would be VBR and this would be VR, and that's why it drifts like this. Okay, so in that case the time taken, that is 10 minutes, would be equals to the width D upon VBR. This is the first result. And similarly what I can write, V of river into 10 minutes, that is equal to 120 minutes, 120 meters, sorry, not minutes. So V of river is 120 minutes upon 10 minutes. Write it like this. And for the shortest path, he goes like this, so that this is what VB comes out. So in that case, the VB comes out as VBR square minus VR square, so time 12.5 minutes is equal to D upon under root of VBR square minus VR square. This is the equation third that you have got. Now you have to find the width of the river. So for finding the width of the river, now what you should be doing, you need to do what? So I have this value, with this value of what I have the value of VR. So if I have the value of this VR, what I can write now, so let's first divide these two equations. So what I 12.5 by 10, I can write as 5 by 4, dd get cancelled, and this gets as VBR upon VBR square minus VR square. Okay, so what we have, let's say square it out, 25 VBR square minus 25 VR square equal to 16 VBR square. So now 25 VR square is equal to 9 VBR square. So from here what I can get, VBR is 5 by 3, I can write 5 by 3 of VR. And what is VR? That what we had, 5 by 3 into what we have, 120 meters by 10 minutes. Now substituting this in the first equation, D would be VBR into 10 minutes. So what we have, VBR 5 by 3 into 120 by 10 minutes into 10 minutes. So this. So 5 by 3 into 120. So what we get, 45 is a 200 meter. Go for option D. So small bit of calculative, but you can make out. It's not that tough, I suppose. Next one, this is a standard one. I remember. Friction coefficient between the board and the floor is mu. Find the maximum force that the man can exert on the rope so that the board does not slip. So look at this. For the board, I can see this is the board. This force is T, and this T is trying to go it there, and this would be the friction that would be stopping it. So it limiting case, T max for which it won't move would be equal to Fs max. And Fs. Now for finding Fs max, let me draw the complete diagram of this men plus board. So because it pulls this string with the force T, so the reaction it has, it would be T downwards. Plus it has its weights mg, this has its weight mg, so small mg plus small mg, and this would be normal. So the normal force here would be not total mass, it would be m plus mg minus t, because this of this t effect. So now what we have, and this is mu s n, and what is n? M plus mg minus t. So now this is T again, I write it. So what we'll have TT, you remember this force it generates is equal to tension, so that F is equal to T. So I'm writing it as T only. So what we have, T 1 plus mu S is equal to mu S M plus mg. So now what we have, T, the 1 plus mu S would go and divide. So go for option B. That seems to be the most appropriate one to me. Next one, 12th. Radionucleus with half-life this is produced in a reactor at a rate this. During each decay, energy is released. If the production of a started at t equal to 0, then the rate of release of energy at 3240 seconds is now. This is an interesting one. So half-life is 1620 seconds, produced in a reactor at a constant rate of 1000 nuclei per second. During each decay, 200 MeV is released. The production started at t equal to 0, rate of release of energy. So what is the rate of release of energy? So I need to first find out the number. So here what we have, this nuclide A is coming. This is a constant rate R, but it decays by that lambda. So what I can write, dn by dt, the rate of formation is fixed, but rate of decay would be lambda n if n is the number at time t. Okay, you must have done analogous to that di by dt equal to E minus IR that we do in the LR circuit. So if you solve it, it is dn upon R minus lambda n equals to R dt, putting the limit 0 to 2, put it in the limit 0 to n, and if you do that integration, what you will get? You will get minus 1 by lambda ln of R minus lambda n upon R equals to what we have, this R, okay, this R, this is simply T, okay, it was simple dt, so that is equal to T. So what we have, 1 minus lambda n by R equals to e to the power minus lambda t, so n will come out to be R by lambda into 1 minus e to the power minus lambda t. Rate of decay at this moment is this one only, lambda n. So the rate of decay would be equals to lambda times n. So lambda times n is R1 minus e to the power minus lambda t. So substituting it, R is 1000, 1 minus e to the power minus lambda would be ln 2 by t half, which is 1620 into 3240. So what it is 2, so it becomes e to the power minus ln 2 to the power 2, that becomes 2 to the power 2 in division, e to the power ln x is x you are using, so 1 minus 1 by 4, so that is 750. So 750 decays per second, that is it is getting, so energy would be 750 into 200 MeV. So 75 into 2, 150, so 1.5 into 10 to the power 2 MeV per second should be the answer that I should get. Okay, so 200 into 750, that is the value that we should be getting. So 1.5, not 10 to the power 2, it is, sorry, okay, that is why I was checking, it is 10 to the power 5, that option is also there, so A is the right one. Next, disk of radius r, mass m, is pivoted at its rim and is set of a small oscillation if simple pendulum has to make the same period. So it is what you know, it is, we call it as the physical pendulum. So because it is a disk, I can directly write time period is 2 pi root of I by mgl, if you remember that. L is the distance of cm from the hinge point, which is r here. So I is what? I about this axis, this about this axis mr square by 2, that would be 3 by 2 mr square upon mgl. So it is 2 pi under root of 3 r square, on L is also r, so that will become 3r by 2g. So comparing with the simple pendulum, the length should be 3r by 2. That is what we can write. So option D is the most appropriate one. Next one, 14th example. In a photoelectric effect experiment, stopping potential changes by 30 if we change the frequency of the radiation. The magnitude of the change in the frequency is, okay, if we change the frequency of the radiation. So let's find it out. What we know, EV naught is equal to h nu, sorry, h nu minus phi. That is what we write. So V naught is h by e nu minus phi by e. So y equal to mx by c. So I can directly write delta y by delta x. Here it becomes delta V naught by delta mu. That will always be equal to h by e. Delta y equal to m delta x. So I can write it like this. So delta nu would be, you can make it out, delta V naught into e by h. So delta V naught is 30, e is 1.6 into 10 to the power minus 19, and h is 6 into 10 to the power minus 34. So doing this is 10 to the power 34, 19, 15 to 10 to the power 16 into 1.6 into 3 by 6. So 0.8 into 10 to the power 16, or 8 into 10 to the power 15 seconds per second. So it's not a tough one. Next we go. The length of a metal wire is L1 when the tension is L2, and T2 when it is natural length. We have done this question so many times. Let L1 be L0 plus extension in L1, L2 be extension L0 plus delta L2. We know delta L1, that would be L1 minus L0 is equal to FL upon AY, that is T1 L0 upon AY. Similarly, L2 minus L0 is T2 L0 upon AY. Divide both the equations. Divide them. This goes, this goes, this goes, this goes. So T2L1 minus T2L0 is equal to T1L2 minus T1L0. Okay, so now what we have, T2L1 plus L0. Okay, no, okay, this is, I'm doing there's a mistake. I need to find for L0. So L0 taking terms here, what I have, T1 minus T2L0 is equal to T1L2 minus T2L1. So L0 is T1L2 minus T2L1, sorry, T2L1 upon T1 minus T2. So this is the way we will write. And if it reverses T2L1 minus T1L2, that is one and the same thing. So it should be the reverse thing. So option C is the most appropriate. You must have done this question also, very common question. So now next one, 16th. Light rays incident on the lower medium boundary as you are seeing at an angle 30, which of the following if mu2. Okay, so first let me check for TIR. So for TIR to occur, first of all I have 4 into sine 30 should be equals to mu2 into sine 90, I should write. So mu2 for TIR comes out as 4 sine 30 by sine 94 by 2, that is 2. So if mu2 is greater than sorry, less than 2, this TIR will occur. So if mu2 is let's say what we have less than 2. So if mu2 is less than 2, TIR will occur. And for mu2 equals to 2 is good, it simply goes like this. Okay. So now for mu2 greater than 2, the total deviation is 60 degree. For mu2 less than 2, so for mu2 less than 2, what do you have? You will have like this. In that case, the deviation would be like this: 180 minus 30, 30, 60, that is 120. So if mu2 is less than 2, deviation is 120. So this is wrong, this is wrong. Now for mu2 greater than 2. So for mu2 greater than 2, what we will have now? So now the deviation won't depend on mu2, it will depend only on 4 and 2. What I can write? 4 sine 30 would be equals to 2 sine emergence. So sine emergence comes out as 4 sine 30 is 1 by 2 into 2, that comes out as 1. That means it goes like this. It goes that is sine theta is 1, so emergence angle would be like this. Okay, so in that case the total deviation if I have to write this angle is 30 degree, this angle is 60 degree, so deviation would be this much, because it instead of going, and it won't go like this, but instead of this it goes by this, so it's bent by 60 degree. So if mu2 is greater than 2, total deviation is 60 degree. Go for option A, that is the most appropriate I can see here. This doesn't depend on this, the relation between these two doesn't depend on the third medium present in between. Okay, next one. 1,000 kilohertz carrier is amplitude modulated by a signal of frequency. There's the channel width in this case. Here for the signal, the peak frequency is 4,000, and we know the channel width would is equal to twice of the f max, in that is signal. So 4,000 into 2, that is 8 kilohertz is going to be the channel width in for this particular case, that you should remember. Okay, next. A pendulum clock is 5 second fast at a temperature of 15 degree. Okay, 5 second fast. That means it will gain time. And 10 seconds slow at 30, that means it will lose time. At what temperature it will give the correct time? Definitely it would be between 15 and 30, and all options are there. Okay, so we need to be careful. So for the first, it is 5 second fast, and that is 10 second fast. So it is not given out up to how much time. So what I can see, delta t by t is equal to half alpha delta t. So for the first one, what I can say, write it as small t. I take the duration to be the same, and delta t is denotes the temperature. So that duration, let's say 5 second fast, so 5 upon t is equal to half alpha into, let's say correct temperature is t, so t minus 15 here. And then it is 10 seconds slow, so 10 by t. If I now have to write it 30 minus t, that you can understand. So dividing by this t will get cancelled, not this 10 will not cancel. I have cancelled it, but it is not cancelled. Half alpha goes. So 1 by 2 is t minus 15 upon 30 minus t. So you can directly make out it should be 20 from the data, because for 20 this is 5 and this gap is 10. So 5 is to 10 is 1 is to 2. So go for 20 degrees. Next one. Find the dimensions of electrical permittivity. What is electrical permittivity? That is epsilon naught. You must have done this question. What we write for epsilon naught, what I should write as, I should write F as 1 upon 4 pi epsilon naught q square by r square, like this. So this is dimensionless. So dimension of epsilon naught q square is a square t square, r square is L to the power 2, F is mlt minus 2, sorry. So now what we will have, m minus 1 and L minus 3, T4 and A2. So A2, m minus 1, A minus 3, T4. So the first one is the correct choice. Go for option A. Next one. 20th. A block A and B, two blocks, sorry, shown in the figure have masses 5 and 4 kg. The system is released from rest. The speed of B after A has traveled a distance 1 meter along the line is. Okay. So first of all, so here what we'll have, this is a question of constraint. So if this A goes down by distance x, we know this will go up by x by 2. That is the constraint relation. You can imagine it like if b goes 1 meter down, this 1 meter will be here, 1 meter, 2 meter string will be needed, so he has to go by 2 meters. So if x goes by 1, it goes up by 1 by 2. So a loses energy. How much? 4 into 10 into 3 by 5, because of that sine 37 into 1. It gains. How much it gains? 5 into 10 into 1 by 2. Okay, it gains this much image energy. Plus, by the same logic, if its speed is v, its speed down would be 2v. So it is half into b is 4 into v square plus half into 5 into 2v ka whole square. So what we have now? This is 2, 6, 12. This is what we have. This is what we have 12 and okay, I have written it wrong here. The data is written wrong. This is 5 kg and this is 4 kg. Okay, so let me redo this. So it is 4, 2, 3, 6, 6, 5 is a 30 I have, and there I have 20 plus what I have here, 2v square plus what I have here, 10v square. So it comes out as 12v square equals to 10. So v comes out as the root of 5 by 6 meter per second as per me. So let me check root 5 by 6. Yes, this is the option C I have. So this is C. Okay, let me see next one. And the next one, okay, so the single correct are over. Now go for the multiple, not the that is the numerical one. Okay, boat covers 24 km upstream and 36 km downstream in 6 hours, while it covers 36 km upstream and 24 km downstream in 6.5 hours. The velocity of the current is okay. So let's say VBR and VR be the two speeds. Now the first case, for down upstream, let VUB would be VBR minus VR, and V downstream is VBR plus VR. So if I do this, what I have, time taken is 24 upon V upstream plus 36 upon V downstream, that is equal to 6 hours. Next, 36 up, that is V up, plus 24 down, that is VD, that is equal to 6.5 hours. Okay, so this is what we are getting. So now let's say better take this inverse as x, this inverse as y. So what we have, I can rewrite as that 24x plus 36y equals to 6. 36x plus 24y equals to 6.5. Okay, so now what I can do, let's say multiply this by 1.5 and subtract. So this goes 36 into 1.5, that is 54. 54 minus 24, that is 30y, that is 9 minus 6.5. So this y comes out as 2.5 by 30. So what we have, this is y, so 1 upon y, we need to remember what is y is this, 1 upon v downstream, that is 1 upon v downstream is 2.5 by 30. So v downstream is 30 upon 2.5, which I can make out as 12. Okay, so this is 12. Now putting this value, this is value here, what I get here, 24x plus 36y, which is 2.5 by 30 equals to 6. So this is 6, this is 5, this is 2, this is 3. So 24x equals to 3. So x comes out as 1 by 8. That means v upstream would be 8 km per hour. Okay. Now for VR, I should subtract VD minus V up would be equals to 2 VR. So VR is difference of the 2 divided by 2. So 12 minus 8 by 2, that is 4 by 2, 2 kmph. So it's a good question. You need to be careful. So 2 you have to write, you don't write up to unit. Okay, next. 20 seconds. So it was a nice way of doing that. Next. Non-conducting rod length and linear charge density, where x is the distance from it, rotating with constant angular speed omega about the same, and if the angular velocity is large, then the magnetic dipole moment of the system is okay. So the magnetic dipole moment of the system, let us take at a distance x, go and take this small dx. So what I say, what is the charge on this dq? This is lambda dx, which is lambda naught x dx, and because it is rotating, so it will be circulating a current. So the current would be created as I would be, or di would be, what I can say, what we have, qf. So di would be equals to dq into f, and f is what, omega by 2 pi. So the magnetic moment d mu would be nia. So n is nothing but I into a, that is dq omega by 2 pi into area. Area becomes pi x square. So if I write it completely, what it becomes, omega pi and pi can cancel to x square lambda naught and again x, so x cube dx. So for the complete integrated, lambda naught omega by 2 x cube dx limits will go from 0 to L. This will be the complete mu. So lambda naught omega by 2, this will become L to the power 4 by 4. So going by this comes out to be 8 as per me, and this is the answer given. Okay, next one. The instantaneous velocity of point B of the given rod of length 0.5 meter is 3 meter per second. Okay, what is the angular velocity of the rod of the minimum possible magnitude for the minimum possible magnitude of the velocity of the end A? So for the minimum possible magnitude of the velocity of the end A, I'll assume um, it won't be having any velocity in perpendicular direction, only B is having in perpendicular direction, which is equal to VB sine 60, that we write it as omega into L, that directly you write it as omega R. That is the way you typically write. So what we need to find, minimum possible angular velocity, okay, so omega minimum would be VB sine 60. VB sine 60 is what we have, 3 sine 60, 3 root 3 by 2 upon L. L is what is length? L is given as 0.5. So 0.5, so 1 by 2, 1 by 2 get cancelled as 3 root 3. So 3 into 1.7, 17 threes are 51. So the answer would be 17 threes are 51. So it should be 5.1, I suppose. If taking it as 1.7, 5.1 should be the answer, not 5.2, which is given. It would be when you take it as 1.73. Okay, next. In the YDSE experiment, the distance between the slits, distance of the slit is given, the wavelength of light is used, I naught is central maxima. Minimum distance of the point where the intensity is I naught by 2, we know this is I naught by 2 at a point where the distance is lambda by 4. Okay, so I can directly say if I write the formula, I max cos square 5 by 2, and 5 by 2, 1 by 2 into 5, 5 is 2 pi by lambda into delta x is d sin theta is y by d. I can write it like this. So what you need, this is 1 by 2 cos square, so 1 by root 2 would be the, if I do take the cos, that is for 45 degree, I can directly write this value should be pi by 4. So this comes out to be pi lambda d y by d equals to pi by 4. Directly I can make it out. So pi goes, y goes as lambda d by 4d. So lambda is 6 into 10 to the power minus 7, I can write. D is 1.2. 4 into 0.25, that is 25 into 10 to the power minus 4, I can write. So this is 10 to the power millimeters. Okay, 6 into 10 to the power minus 3 I should write, into 1.2 upon 25, 4 is 100, 1.2 into 6, so 12 6 is 7.2, so it would be 7.2 into 10 to the power minus 5 meter as per me. So the answer should be 7.2, and it is given like 7.2. Yes. Next, the last one now. An observer standing on a railway crossing receives frequency when the train approaches and recedes. Okay, so what we have, 2.2 would be equals to f naught, because source is moving, it would be v upon v minus v of train, and 1.8 would be f naught, v upon v plus v upon v plus vt. So divided, 11 by 9 is v plus vt upon v minus vt. So what we have, 11v minus 11vt is 9v plus 9vt. So what we have, 2v is 20 vt, vt is 1 by 10 of v, 1 by 10 of v, that is 30 meter per second. That is what I am getting. So the answer should be 30 as per me, and it is given 30. Okay, so this was today's paper. Keep sharing the channel. Thank you all.